Hi guys, this video is a quick introduction or review of C++ exceptions. Exceptions are a solution to the problem of reporting runtime errors. A runtime error is when something doesn't work for your program at runtime. Runtime means while the program is running, so these are distinct from compile time errors like a syntax error. A runtime error happens after you've compiled the program and run it, and it encounters some situation it can't deal with while running. Robust programs have to detect and handle runtime errors. So we're familiar with these kind of situations. You often have a situation in an app where maybe the network is down, and if the network is down, we don't want a mobile app to just crash and vanish. We want it to maybe say a message like, sorry, the network is down, try again later, something like that. We want to write that kind of software that handles these situations. This is a headache in programming. It's a long-standing problem dealing with runtime errors, and frankly, it's a challenge in pretty much every programming language I've ever used. Different languages have different ways of dealing with this, and none of them are all that fun, to be honest. They're all a little bit complicated. Kind of an older approach from the C programming language is to have return codes. So the idea there is that we use the return value of a function to indicate whether a runtime error occurred or not. So for example, I could write a function using that style here. This is called readInt. The goal of readInt is to try to read an int from standard in. This is an interactive program where the user can type in a value on the console. And we want to store it in the variable called result. I have to pass result by reference in order for that to work. We'll review references later. It's not critical to understanding the issue here, which is the error return codes. So on success, if the user types in an int that actually works, then this function readInt will set result to that value that was read and return true to say that actually worked. On failure, meaning the user typed in something that wasn't an int, the word hello or something, HELLO, that's not an int, can't be interpreted as an integer. So if that happens, a failure condition, we set the result to the number 0 and return false. Here's my definition for the function. I have an int called gut. It's for what we actually got from the user. I use cin to read that in and test if that actually worked. As you may or may not recall, when we implicitly convert cin to a Boolean, as I did in this if statement, this produces a true value if cin is good, meaning the previous extraction worked, and this expression evaluates to false if there was a formatting error or other error in that extraction operation there. So if that extraction operation on this line worked, then this is the succeed case. The result is assigned to that gut value and I return true. Otherwise, meaning an error happened, I set result to false, set to 0 and I return false. So that's one way of handling this, but it's not perfect. There are some drawbacks to this. For one thing, it gets tedious in long functions. The readInt function here only has to check for an error once. However, in longer or more complicated failure-prone operations, sometimes you might have to check for an error 5 or 6 or 10 times, and it gets tedious to write this if there's an error, then return something. Every one of these risky operations has to write an if like that. If a problem happened, return an error. That's pseudocode, of course, not valid C++. So that gets old. Also, another problem is that the caller gets no context for what happened. Sometimes in order to deal with one of these problems, you need to know what happened. Like, what went wrong? What we only get here with this Boolean return code is just it didn't work. Either it did work, Boolean true, or it didn't work, Boolean false. There's no kind of who, what, where, when, or why of this error back here. So if I call the readInt function and I get false returned to me, I don't know what went wrong. I don't know if the user typed in something bad or if there's some kind of problem with cin right now. I don't know. And so it makes it hard for me to present a meaningful error message to the user or to handle it. In my app example, if the network is down and I just get a Boolean return to me false, I can't say the network is down. All I can say is something mysterious like there was an error, I'm sorry, and that's not satisfying to anyone. So one solution to this problem that uses object-oriented principles is exceptions. An exception is an object that represents a specific runtime error. And usually we use class types for exceptions. In C++, technically, you don't have to use a class, but the standard practice is for an exception to always be a class instance. There are two ways of dealing with exceptions. One is to throw an exception. They use that verb to indicate, you're kind of like throwing a problem at someone, kind of throwing it in their face. Sounds a little bit rude, but if something went wrong, you have to communicate that. So to throw is to signal that an exception has happened. That's done by the risky code. So if you're writing some code where something might go bad, then you have an if statement that says, if something went bad, then I throw a exception object. And here's an example of that. You could say if cin is bad, then throw an invalid input exception. And this would work if invalid input exception is a class type that has been defined. The caller catches an exception. Kind of the inverse of throwing is catching. So anytime a caller calls a function that might throw an exception, it should attempt to catch that exception. So for example, if I call that readInt function, and now readInt has been refactored to throw a invalid input exception when a problem happens, I would say try. In between braces here, that's called a try block. This region of code here is being scanned for exceptions. And if this block of code happens to throw a invalid input exception, we catch it here. The pattern is you say catch and the data type of the exception you're trying to catch and the name of the exception object you're catching. And if that happens, then you handle it somehow. So in this case, I'm printing out to CERR, the error stream, a descriptive message, invalid input halting or something like that. So that's how you can throw and catch exceptions. We're going to be using this a lot all semester, so I don't want to go through a ton of examples. A lot of the code we write will have more examples. The C++ standard library has some predefined exception classes so that you don't have to define them yourself. And a best practice is to use the standard exceptions when you can. If there's no standard defined exception that fits your situation, in that case, it does make sense to create your own exception class. And an exception class is just a plain old C++ class. There's nothing special about it. There's no exception keyword or anything like that. It's just a class you create. So you can see the standard exception documentation. It has a list of all of these standard exceptions. The example that we're going to do in the next video is going to show you how to use some of them.